Every smartphone, laptop, and gaming console depends on one tiny invention. The computer chip, smaller than a fingernail. This tiny chip performs billions of calculations every single second, but have you ever wondered how something so small is manufactured with unbelievable precision? The journey begins with one of the most common materials found on Earth. Ordinary quartz sand. Hidden inside the sand is silicon. The essential material used to build modern computer chips. The silicon is purified inside massive industrial furnaces until almost every impurity is completely removed. The purified silicon is melted again, creating the foundation for one of the world's most advanced manufacturing processes. A tiny seed crystal slowly rises from the molten silicon, growing into one enormous single crystal. This delicate process takes hours, because even the smallest mistake can ruin the entire crystal. Once complete, the giant silicon crystal is carefully moved to an ultra-precision cutting machine. Diamond wire saws slice the crystal into incredibly thin silicon wafers with microscopic accuracy. Each wafer is polished until its surface becomes smoother than a mirror. Ready for the next manufacturing stage. The polished wafer enters one of the cleanest manufacturing environments ever built by humans. Powerful air filtration systems remove microscopic dust particles floating inside the cleanroom every second. Instead of human hands, precision robotic arms transport every wafer safely between advanced manufacturing machines. The wafer is thoroughly cleaned using ultra-pure water to remove particles invisible to the human eye. Next, a light, sensitive chemical called photoresist is carefully applied onto the spinning silicon wafer. As the wafer spins at incredible speed, the liquid spreads into a perfectly uniform microscopic layer. The coated wafer now enters one of the most expensive machines ever built, the UV lithography system. Powerful ultraviolet light projects microscopic circuit patterns onto the wafer with astonishing nanometer precision. Those invisible patterns will eventually become billions of tiny transistors working together inside a single processor. The wafer moves through chemical development, revealing the circuit patterns hidden inside the photoresist layer. Plasma etching removes unwanted material with atomic precision, permanently shaping the microscopic electronic circuits. The first transistor layer is complete, but dozens of additional layers are still waiting to be built. Another ultra-thin material layer is deposited across the wafer, preparing it for the next generation of microscopic circuits. Microscopic copper pathways are created, allowing billions of transistors to communicate at incredible speeds. The wafer is chemically polished once again, creating a perfectly flat surface for the following manufacturing layers. This entire process is repeated dozens of times until the complete processor structure is finally finished. Advanced AI-powered inspection systems scan every nanometer, searching for defects impossible for human eyes to detect. Only flawless wafers continue forward, while defective sections are automatically identified and removed from production. A precision diamond blade carefully cuts the finished wafer into hundreds of individual computer chips. Robotic vacuum tools gently lift every chip and place it onto its protective package with microscopic precision. Tiny electrical connections permanently join the silicon chip to its package, allowing signals to travel perfectly. Every completed processor undergoes demanding electrical and performance tests before receiving final approval. Approved processors are shipped worldwide and installed inside phones, computers, vehicles, medical equipment, and powerful AI systems. From ordinary sand to extraordinary technology, every computer chip is a masterpiece of precision engineering that quietly powers our modern world. Thank you for watching Scale Factory Docs. If you enjoyed this documentary, don't forget to like, subscribe, and turn on the notification bell. Which factory should we explore next? Let us know in the comments. See you in the next documentary.